Harled ETS is a program that makes it easier for our clients to manage, organize, and locate their equipment. Using Harled ETS, you'll be able to track and update the condition and status of the equipment, making it much easier for anyone interested in the equipment to locate it and find out about its condition without having to communicate in person. With that said, let's get right into the wireframe. Throughout our development, we have put a heavy emphasis on making our design modern, user-friendly, and intuitive. Upon entering, our clients will be able to log in to their own accounts. Next, they will be greeted by the equipment dashboard, where all of the data relative to their equipment will be displayed. On the top right, using the button labeled Add Item, our clients can use this to add new pieces of equipment as well as input data on their condition and location. In order for a client to locate a specific item on the equipment dashboard, they can scroll through the list of equipments they've inputted at the bottom of the page using the next and previous buttons with the page numbers labeled. Alternatively, they can use the search bar at the top of the page and type in the keyword of their item in order to locate it quickly. By clicking on each individual item, a panel will open up on the right that will show more information about that specific piece of equipment. The user will also be able to find out about who is responsible for this piece of equipment, as well as look at who used this equipment before the client and where it has been. In order for a user to locate the item, they will have to click on the Navigate to Item button. This button takes them to another dashboard. In this dashboard, they will find a visual navigator map with their location as well as the location of the item on it. Moreover, it will also include the distance between them and the item, as well as how to get there. Finally, it will also show information about the condition and status of the item, as well as the weather at their current location and at the location of the item. Finally, the user can click on the Settings button at the top right side of the page in order to toggle appearance settings such as dark mode, language settings, as well as notification settings. Our mobile design features the same functions as our web design, however, it is much more compact. As you can see, users can also log into their own accounts, where they will be greeted by a dashboard containing all the equipment and items they have inputted into the system. Under each title, they can see the status of the item, that is, whether it's missing or available, and they can also see the location of the item. If they choose to click on each individual label of the equipment they have inputted into the system, they can further see how to navigate to the item, as well as the item's history. Similar to our mobile design, when the user clicks on the Navigate to Item button, a dashboard pops up. In this dashboard, there is a visual navigator map that shows the whereabouts of you and your item, as well as the distance in between you and the item. Moreover, it shows how to navigate to the item, as well as information surrounding the weather of the location you are at currently and the location of where the item is at. Finally, it also shows the item's status and condition. They can also access the Settings tab, where they can customize the display of the program, as well as the language settings and the notification settings. In order to find an item in our mobile design, users can use the Search tab. In order for our user to find the item that they are looking for in the main dashboard, they can type in the keywords of the item in the search bar in order to locate it.
Hi everybody, this is the backend team. My name is Barath and I'm working with my colleague Nathan on the backend implementation of Harled's equipment tracking system. So really quick, we're going to brief you guys through our system design and architecture for the project. So where it basically starts is the client, and the client represents the entire front-end application of the equipment tracking system. So the front-end client, which runs on a user's device, is ready to send and receive information from the backend server in a JSON or XML format. So basically where it starts is that the client makes various kinds of HTTP requests to the server as the sole means of interacting with it. This is actually the first point that the client interacts with the server. And for this project, the most common requests made will be get and post. So get is basically retrieving data from a resource, and post is creating or updating data in a resource, both with a content type of application slash JSON. So now I'm going to hand it out over to Nathan, who will go more in depth with Django REST API web server that we implemented for this project.
The web server is made up of various components which are all written in Python. This implementation looks similar to Django, except it works as a REST API rather than serving HTML pages made from templates. URL patterns. API endpoints are defined in urls.py and mapped to views functions, which are defined in views.py. The server will receive an HTTP request to one of these URLs, which it can then use to begin forming a response. Views functions are where we define how the incoming requests will be handled by the backend. All the data retrieving, formatting, and processing will be triggered by these functions. For example, we can define a URL pattern that is mapped to a views function that takes an object's ID as a parameter. We can then have this function retrieve and return the object's last seen coordinates back, just as a regular Python function would. As previously mentioned, the views function will trigger the formatting of data. This formatting is done by serializers, which we will define. The serializers take input as a Pythonic model object, which are defined in models.py, and then convert them to a JSON or XML format, which is then returned to the views function. Models. Models are the sole way of interacting with the database. Models.py is used to define individual data objects in a Pythonic object-oriented format. For example, we can define a class called TrackedObject, which can contain attributes we define such as location, name, or last updated. For special data types that deal with geography such as location are why we use a Postgis Database, which Barath will talk about.
So the database that we used for our project is the Postgis Database, which is a fork of the popular Postgres database, which adds additional support for geographic objects and allows queries related to location from SQL. And as Nathan mentioned, models.py actually interacts with this database. So how it works is that Django can handle all the classes we create and update the database by making small SQL generating Python scripts called migrations. And because Django is powerful enough to generate SQL automatically, we don't actually have to interact with the database directly through SQL, and it can all be done through Django or the Django shell.
In order to consistently and reliably keep track of objects, the system will need to have its own way to automatically handle location data. This equipment tracking system will use both RFID and GPS data. Tracking objects from RFID and GPS data will be done by a separate and special process the service will spawn. This process will actively listen for incoming data, whether it be GPS or RFID. This process will then serialize this data into a JSON format, which is then sent to the server through an HTTP POST request. This relationship between the web service and the signal listener process will be kept secure through a key system to avoid any fraudulent data being fed into the system. Every communication between the process and the web service will use a cryptographically generated key, which the web service will then use to authenticate the identity of the signal listener. This key and API-based system also allows for easy scalability, as more listeners can be added over time if needed.
The JSON or XML formatted data to the views functions, the web server will send the formatted data back to the client as a response to the GET request. This action concludes the path of a request made by the client that was sent to the web server. So now the front-end team takes this information, formats it, and displays the data to the user, and the server is no longer used until another HTTP request is made. So that's basically how the backend system works.